Hey everybody, welcome back to the shop and the G&E Shaper. And today I think I'm going to go ahead and start my very first real project on the Shaper here, as far as making something on the Shaper. And what we're actually doing is making something for the Shaper, using the Shaper. I've got some pieces of material here cut, and I had said in a previous video that what I would like to do is make some spacer blocks that will go in this original lantern style tool holder that will back up some tool bits. So I want to be able to use some of my 1-inch square tool bits like this, but they're not wide enough. You actually need a rectangular tool bit to properly fit in there and be able to tighten down, much like the shank of these tool holders here. So the 1-inch tool bit, it's wide enough to go in there, but the screw is not long enough to clamp it down. So what I need is something behind it. So what I'm going to do is, I've got this piece of H13 tool steel, and I cut it into 3 pieces because it was just a shade under 12 inches long. So I cut them all 3 and 15/16, and we're going to make little T holders, little T-shaped holders that will fit up in this lantern tool holder. And I'm going to have a slot milled in it, or not milled but shaped, that will hold the tool bit square like that. And we're going to have an 1/8 of an inch cut onto each side, so it'll be in the shape of a T that I can slide down in this tool holder. So it'll have a shoulder there that will hold itself in there while I stick the tool bit in there, and then be able to tighten the screw down. So I'm going to go ahead and make up 2 of them right now. The third one, I don't know what size slot I want in the middle yet, so I'm just going to leave this one without a slot, but it'll be shaped in, T-shaped anyway, cut on both sides. And we'll just do all 3 of those at the same time. So this is another one of the tool holders that I have here that I'll utilize, and this is a 3/4 inch wide shank tool right here. This is the Armstrong number 41, and this is the multi-position tool holder that uses a 3/8 square tool bit. And the one that we have in the Shaper now that come with it, this holds a rectangular tool bit, 1/8 wide by 3/4 on the height right there. And I looked around the shop, and surprisingly I don't have any more of these tool bits this size. I wanted to try to have an assortment of different grinds for this tool holder here. So I found some on eBay. I found a pack of 10 of them, and I bought those. I'm waiting for those to come in. That way I'll have basically 20 different ends that I can have some grinds ready for this tool holder right here. But for now, we're going to just make use of this tool holder. It'll do everything we need. And this is the 3/8 tool bit that will go into this one right here. This is the number 41 tool holder that takes the 3/8 tool bits, like so. All right, like that. So we'll be able to utilize that. And at the same time, I've got some of these in 3/4 size tool bits as well. So even if I find some rectangular tool bits, there's some out there, I believe, on eBay that's like 3/4 inches wide by, 1.5 tall or 1.25 tall. So I'll be able to pick some of those up to use on the Shaper as well. And then this is another tool holder that I might be using here. This is number 4S Armstrong tool holder for a 1/2 inch tool bit. This is for the high speed, so whenever you stick the tool in there, you're at an angle, you're in a back rake angle. So this was one of my dad's right here. I'll clean it up and we'll make use of it on the Shaper as well. Okay, so what we're going to do is stack these 3 tools in here. We'll just stack these 3 in here like so. We'll turn the vise to 0, indicate it in, and then we'll just cut each side 1/8 inch off each side, okay? Got the vise turned to 0 degrees and clamped a nice parallel in there. I'm going to use my Starrett number 671 right angle attachment on my 1-inch travel dial indicator, and we'll use this to sweep back and forth across here to get it indicated true and get it set in here. That end's low, so it needs to go around that way a little bit. 4/1000. I'm going to tap it while it's going. That looks good right there. We'll snug the 4 nuts up and then give it a check. See how, if it stays. I'd say a 0.5 We're going to call that good. Alright, I got my parallels spaced out in here where all these will sit in there like so. We're just going to kind of go right to the middle of the vise. I'm going to use my pretty little Lufkin double square. Square it up on the back of the jaw here. All of them are square on one end. Tighten the vise up. Okay. And then what we're going to do is we're going to have a 1-inch shoulder up here on this side. And that will space the blocks evenly across the knurled pad up here on the rocker style tool head. 1 inch from the end, so yep, that'll work. I'm not getting too crazy with the tolerances on this. This is a simple little part and one that we're going to be doing just for as like a practice exercise on the shaper here. So there's our 1-inch line. We're just going to have a 1-inch gap right here. Our cut will be from this edge to this line right there. And then I think once I get close, I can just measure this with my calipers and just move it over as needed to get it within 1 inch. We're going to use one of my personal favorite machine shop books, Technology of Machine Tools. I picked this book up when I was probably 15 years old at a neighborhood yard sale before I even realized I was going to be a machinist. This is an excellent book. This is just like that other one I showed on SNS that I just got. We are going to open up to this chapter that is on shapers, and I'm going to show you this very first picture. I've always been intrigued by that picture right there. And this is one of the reasons why I wanted a shaper. Look at that cut right there. I have no idea what the depth of that is, but if I had to guess, that's going to be between 3/4 and 1 inch of a depth of cut. And that is easily made on a shaper right there. You can make much more than that actually. I've never done it, but I hope to get to that point real soon, in practice anyway. So this is a really good section in this book on shapers and slotters. I'm not going to go through the whole thing. I showed you this right here. This explains, excuse me, this explains why your backstroke is faster than your cutting stroke on that because of the degrees of arc that is going around in the circle, all right, on the pivot point right there. But let's just go ahead and go to the next chapter right here. And this side right there, while you're looking, explains how a hydraulic shaper works, which are awesome. This is the style shaper that I had in mind that I was going to be hunting for, a Cincinnati hydraulic. Those are awesome. But what I'm showing you right here is shaper, speeds, and feeds. And this gives machine tool, tool steel, cast iron, and brass. And I'm going to consider machine steel to be something like low carbon steel, such as cold rolled 1018, that kind of material. Tool steel being a harder medium to high carbon steel, you know, so I'm going to consider my Ace 13 to be tool steel. But what we're looking at is speed per minute, which for shapers are given in feet per minute, and high speed tool right here. Maybe I'll use a pointer there. High speed tool, and you goes across, and it gives this book gives you in meters per minute as well. You can use this book to figure your metric calculations as well. But we're going to use feet per minute. So we're going to consider our proper speed at which the tool needs to move across the material at 50 feet per minute. That's the speed for tool steel, okay? For a high-speed steel tool bit. That's what we're going to use. And this goes into the formula on how it's calculated, okay? But I'm not going to go into that. It's way too boring. All I'm going to do is I'm going to show you. There's some tool grinds right here. There's the tool that we're going to use. There's the formula right there. This is one of them. There's two of them, and they're both about identical, really. Cutting speed times 7 divided by the length of stroke. And you're supposed to add whatever your material width is that you're cutting. You need to add like 1 inch to that so that you have runoff on the front and the back there. So you just figure adding 1 inch every time that you're going to be cutting a piece of material. So our material I measured is 3 1/8 wide. So I'm figuring 4 1/8 wide. So cutting speed, which is going to be 50 feet per minute times 7 divided by the length, is going to give us our formula, our answer for strokes per minute. This is what they're recommending to run the shaper at, strokes per minute. All right, so there it is, 50. That's our feet per minute for tool steel, times 7, divided by 4.125 inches is going to equal approximately 85 strokes per minute on the shaper. Now the other formula you can use is 0.14 times your cut length, which is 4.125. That gives us 0.577, and you take your cutting speed, divide it by that, 5.577, and that gives us 86.65 strokes per minute, which you see is they're the same, okay? So I don't know if I'm going to run that fast. I'm a little uncomfortable running the shaper that fast, so we're going to slow it down, but I'm just showing you this is what the textbook is telling you how to figure your strokes per minute on a shaper, depending on your length of cut and the material and the tool bit that you're using. This is our tool bit that I put a fresh grind and I honed it really well. I don't know if you can see the shiny part of the hone, but it's really, really sharp. Use a real fine hones to get that in. So we're going to try that and see if that gives us our proper back and side rake to make a chip. And we're going to put it in the number 42 here, tighten it up, then we'll position it where we need the tool holder here. This is your stroke adjust, so you can adjust your ram where you want the stroke to be. So we're going to loosen that up. This you need to make sure that this stays really tight. So I'm probably going to make me a cheater pipe to go on this so that I can give it some additional torque. But right now I'm just using this dead blow. If this isn't tight, if you go to take some really heavy aggressive cuts, this may slide on you. We got our new crank handle right there that you see me make, and this will adjust the ram. Position your tool bit where you want it, tighten it up, ready to go. Using a little machinist square on the back of the vise here, and I'm just trying to square up my tool bit by sight. Actually, it looks pretty good right where it was at. I was just using a dead blow right here to just tap it lightly and get that edge lined up square, so that when we make a cut here, we've got a pretty nice square 90-degree corner. That was pretty good. And the vise handle doubles as the wrench to use on the tool holder up top here. There we go. Now we're touching. Try to. And we'll move the table over. I know we got clearance there. Got our collar on 0. 10, 20, 30, 40, 50. That's 50 thousandths. 60, that'd be a 16th. 70, 80, 90, 100. I need to clean this thing. 10, 20. Let's just go 6. 126. And lock it in. Gauge the feed down here. And our table is all still snugged up. That seems a little tough. Might slow that down. Drop it down some. That's some pretty tough steel right there. Right out of the gate, I did something wrong. I don't know what exactly moved, but I can tell that the tool was actually pulling itself in just a little bit. I'm not sure if it's the backlash or this. I don't see why I do that, but anyway, it's not much. I can tell that it ramped in just a little bit, but we got plenty of metal to clean up there. So I kind of stopped it right shy of the line. Saying about 50 thousandths. That one's about 40. Let's just go, how about 40? That should be 4 strokes with feed. I got my indicator down here, and I watched it do it 4 times, 10 thousandths per stroke. Yeah, puts us right there where we want it. Okay, I got a 0 set down here on this dial indicator, and we're going to go back in there. We're going to make sure that this is cleaned up. So this is what we're going to do to try to get our practice in on the shaper and learn how it's going to react, whenever it cuts, and learn about our tool grinds and which grinds are going to work best. I'm going to continue to read my books and study the different illustrations for the relief angles and things like that. And while you guys are watching this right now, SNS 204 just come out. Been out for about 15 minutes, so I was looking at that. But this is what I wanted to do today, was just kind of get a little bit of practice in. And things like this are great, something that's non-critical, that you can get to feel the machine out and get a little practice in. If it doesn't turn out perfect, then oh well. It'll still work for what we're going to do. It's just a backup shim for the tool holder. We did good on our cleanup cut, but I'm having problems with it. Tried to pull itself down in there, and I've been thinking about what's going on with this, and I might have it figured out. So I've got backlash in this screw, you can see right here, and it's 40 thousandths backlash. It's 40 thousandths backlash. So I think I need to go into this tool head and see if there's an adjustment on this, on the nut in here, like you can do on a milling machine, and adjust it so that the backlash is out. So I believe you're feeding it down, and I believe after you feed it down and you start making those heavy cuts, it's trying to pull that backlash down until it hits the screw. So whenever I make my down feed the way I want, I'm going to have to back off on this screw just enough to remove that backlash out of there, because I believe that's what's happening. It's trying to creep down in there. So we haven't gone into this yet, so it's something that we need to address, so I'll be going into this real soon and taking this all apart to find out what's going on with it. Got some 1/4 inch tool bits down in here on the parallels. I've started to cut on the other side here, and what I'm going to do until we get into this is, I know what it's doing. It's pulling the backlash down. There's a lot of backlash in this screw. So I've already set my depth, which you're going to be screwing it down, and then once I get my depth set, I'm going to very gently just try to back this off, just right there, until it stops. And I've got this lock in right there too. So hopefully by turning that screw back like that, it won't have a tendency to pull that backlash down and dig into the cut. So that's what I'm going to do for now. I can see better results this time. We got a flat cut instead of it trying to creep down into the metal. Just visually watching it creep up on the line there. Got a 1/16 left. Let's make a finished pass here. I just dialed in 20 thousandths because it's not that critical. Alright, I'm liking the finish that it left on there. It's got a smooth feel to it. Alright, that's the thickness that I need, plus the 1/4 inch right there. So that should put us 1 1/8 thick on those blocks. Okay, I got all the blocks deburred, and the T part of it ended up being a little narrower than what I was wanting, but what I did was I went ahead and cut the other side to match, since that one side had this side dug in, and this side dug in and cut deeper. So I just made it work. But look, we got a good fit here. And that'll work. That's what I'm looking for right there. You can drop that in, and the edge will catch it, just like so. And then we'll be able to stick our 1-inch tool bit in there like this, and tighten it on down. All right, be able to utilize some of these big tool bits. So I'm thinking about maybe using one of these now, just like it is, and just square it up and see if we can make a 1-inch wide cut to cut one of these for the tool bit to fit in itself right there. Hopefully that'll cut. I've been getting the machine set up. I'm just about ready now. So what I'm going to do is loosen this. I'm going to square the nose of the tool up on the workpiece here. I've got it sandwiched in some parallels and bump down. Let's see if we can go for it. Something's going to give, or it's going to shove that out of the vise here. We just touched. Now I'm touching on both sides, so looks like I've got just a little bit of radius in the nose of that tool. That's pretty cool. Let me see if I can get you a little tighter shot. Be 10 thousandths. That's exactly what it was going to do. Okay, well, that's not a very rigid setup, so I'm going to have to do something different. I'm going to try to give this another shot. So what I've done is, actually today, my tool bits came in that I bought off eBay. I got a pack of these, a pack of 10, 1/2 by 3/4 by 4-inch high-speed steel. And I didn't pay very much for these. It was a lot of 10 of them on there. And I just ground up one of them, and I'm real happy with the grind. I've got a nice honed edge on there. It's as sharp as a knife, and I've got some back rake in it. So we're going to see if the clamping forces will hold a 1/2 inch wide cut. Now, one of the problems that I probably gave it way too much downfeed. So I'm just gonna do lighter cuts, and hopefully this will work. So we'll come in there and we'll see if we can cut a 1/2 inch wide, and if that works out, then we can just step this over to each side to make our 1 inch wide path through there. And we don't really have to go very far. I mean, we might take a 1/16 out of it because we just want a channel to help center the tool bit. But let's go ahead and give this guy a try right here. And by the way, I don't know if I had pointed out, I went to use a 1/2 inch tool bit in this holder, and you can't suck it down. Once you tighten that all the way down there, 1/2 inch still slides in. So you have to use these rectangular shaped tool bits in this particular holder. All right, so we'll put that in there and lock it in and get it recentered, and I'll bring it back when we're ready to cut. Okay, here we go. That's 2 thousandths here. Okay, that was 2 thousandths. Now that's 4,000. Let's just try that. Man, it don't like that, does it? Alright, so I'll admit one of the problems that I figured out was that when I reset this machine and this tool, I forgot to lock all the clamps, the knee and the outer support out here. So I did all that and it seems to be doing better, but it's still trying to chatter a little bit. There's one of the cuts, so it's doing a little bit better. I'm going to slow it down and see if that'll help too. It's probably not helping the fact that I'm trying to machine tool steel here instead of just some regular mild steel. I think I'm learning the machine a little bit better by doing this because it just seems to be jumpy. Well, I'm not happy with what's going on. I'm going to leave the depth to where it's at right there and just go ahead and step it over and see if it'll cut. I don't know. We'll find out. Trying to feel if there's like any kind of looseness in the tool holder here, up here in the tool head. Really hard to tell. I don't really feel anything. All right, looks like we got 50,000, so we'll see about taking 5 more cuts. All right, there's our 1 inch. Well, I can't really consider the first job a great success on the shaper, but it was a learning experience and I'm getting to feel the machine a little bit more, but I feel like I've got some more things that I need to go in and check out. The chattering issue on the tool surprised me. I didn't think that it would do that. That it could be a combination of things, and that's why I got to experiment with this and continue cutting with it to find out what's going on. It may very well be my tool. It may be the tool in combination with that type of metal, but it could be something loose in the machine, such as the gibs over there, or something further into the machine that I'm not aware of. But we're going to continue to work on it. I would like to go into all this right here. For one, clean it up and see about if there's some kind of adjustment on that lead screw there to remove the backlash. So that's what I want to work on next, is try to get some more of this worked on the shaper here. But the block here works. We can set a 1 inch tool there just like I was wanting. So we'll be able to use these 1 inch tool bits and grind these with roughing type profiles in there for removing a lot of metal at one time, things like that. But anyway, we're going to call this one where it's at, and we're going to come back later and work on the shaper some more, okay?